All right, everyone. How you doing? We're going to look at factoring a trinomial into a product of binomials. And what this is saying is that we're going to do it mainly in one variable, but this pattern happens for if we have a collection of variables. But x plus some number and x plus some other number, when we combine them, we get a particular form, which in this case would be x squared plus ax plus bx plus a times b. Right? That's generic. And so we're going to look at the form that comes out of this and how to reverse it. So one of the things to note, and we tend to talk about it, I'm actually going to scrub this out here to avoid some confusion, and we're going to specifically look at the form of the trinomial we'll have. So my a's and b's will mean very specific things from this point on, and they'll be related to the trinomial. So we say we can write a trinomial as a x squared plus bx plus c. And what these are saying is there's some number in front of x squared, there's some number in front of x, and there is a constant at the end of this all. So if I have, let's find a nice one here to do, x squared minus 6x plus 5. My a equals 1 because the coefficient hanging out in front of x squared is 1. Remember, we don't write 1s a lot. They're assumed to be there because these are things being multiplied or to a power. These invisible 1s. So there's an invisible 1 here. Now b, my sign's positive, but this one's negative. So b keeps that sign of negative 6. And c is 5. And so this is what we mean in this form a x squared plus bx plus c. It's also called quadratic in form, and it comes from squares, and squares form quads. Latin and Greek sometimes falls into English, and we get this idea. But this is a quadratic equation. Or not equation, a quadratic expression. It would be an equation if it had an equal sign. What we're going to do here is we're going to focus on the c term. And so what we want to do is we want to make a table of all the possible factors of c. Well, 5's nice because to get a positive 5, I need 1 times 5 or negative 1 times negative 5. Because a negative times a negative is a positive. In my table of factors, there's both of these. I'm going to label them m and n as my factors for right now. This is just to keep track of them as we talk about the different steps. And in my table now, I'm going to add m and n. So 1 plus 5 is 6, and negative 1 plus negative 5 is negative 6. Well, I want the pair that adds up to b. And since b is negative 6, I want negative 1 and negative 5. And this means my answer is in the form of x, m, now I'm keeping the sign with my m, and x, n, and I'm keeping the sign with my n. And so I get two binomials. Let's check this. The first times the first is x squared. The outer terms is negative 5x. The inner terms is negative x. And the last is positive 5. I collect my terms in the middle. Oops, let me scrolling off the end here. I collect my terms in the middle. And I got what I started with. So these are my factors, x minus 1 and x minus 5. Alright, let's look at a couple examples where the factors might grow a bit. And I will do, let's see here. Trying to find a good one. I had one picked out. I'll stay within the first set, so we'll look at 44. T squared minus 5t minus 6. So again, I want to focus on C, which is negative 6. So I want all the numbers that multiply to negative 6. Let's make my little table here. And so 1 times negative 6 is negative 6. 2 times negative 3 is negative 6. Negative 3 times 2 is negative 6. And, whoops, that's the same one I did. I want that to be 3 times negative 2 and 6 times negative 1. It's usually good to keep your negatives down one side and your positives on the other when this is negative, because you're going to need two different signs. When it's positive, as we saw up here, you get a pair of positives and a pair of negatives for each term. This is a pattern you'll see as you do these more and more. But let's add these together. So 1 plus negative 6 is negative 5. 2 plus negative 3 is negative 1. Positive 1, positive 5. Well, this term here matches our B. We multiply, we get C. We add, we get B. So these are what we want. And so my factors are x plus 1 and x minus 6. And that's all nice. We notice A has always been 1. What we're going to do here is we're going to make A greater than 1. And so we're going to look at number 48. 2z squared minus 4z minus 6. And I hope you can recognize that in the previous form when I had ax squared plus bx plus c, that x was the variable. So it doesn't matter what I name the variable. In this case, it's going to be z. So my a is 2. My b is negative 4. And my c is negative 6. Well, we want to reverse the FOIL process. And in the FOIL process, the leading terms create the a term. So we're going to need 2 times z and 1 times z to get this. But there's a way that we can process this through, especially if this leading term has many factors. And what we do is we multiply a by c. So a times c equals 2 times negative 6, which equals negative 12. And so I want all of my factors of AC. Again, I'll use M and N. Draw my chart. And M plus N. Alright, so 1 and negative 12. 2 and negative 6. 3 and negative 4. 4 and negative 3, 6 and negative 2, and 12 and negative 1. So I'll add these together. It gives me negative 11, negative 4, negative 1, 1, 4, 11. Now I want the pair that adds up to B. So it's going to be this one here. Now what I'm going to do now is I'm going to take M and N, and I'm going to replace B with them. So how does that look? We'll come over here, we'll rewrite this, write it in orange. 2z squared plus 2z, there's my M, minus 6z, there's my N, minus 6. Well, I've taken my trinomial and I've put it into 4 parts. And what this is going to help us do is factor by grouping. I'm going to imagine that there is a divider here. I'm going to focus on the first part of this divider. So this has a GCF of 2z. So I'll pull a 2z out front. And that leaves behind a z plus 1. Now this term, these both have a negative 6. I'll pull out a negative 6. And that leaves behind a z plus 1. Well, notice that I have two terms, and each of them contain this z plus 1 in parentheses. So I'll reverse distribute the z plus 1 out front. And that leaves inside 2z minus 6. And those are my factors. And this is called the AC method. And it combines a table of factors and grouping to work the result. But it works very well. We just have to replace M and N in place of the original B. That lets us group. What does it check? My firsts gives me 2z. Oh, let me scroll down a bit. 2z squared. Right? My first z times 2z is 2z squared. My lasts, negative 6z. My inners, plus 2z. Or sorry, my outers was negative 6z. And my lasts is negative 6. And I'll combine like terms. And I got the trinomial I started with. Right? There, 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 there. All right. And so this process works really well. In the next video, we're going to look at some factoring by grouping, and we're also going to look at what to do in general when you get these problems. We're going to look at some more complex problems in the last section. If the video stops. Doo-doo.